Stop.
Stop.
Okay, good, you can do it.
We forgot to teach you how to stop clapping yesterday that caused all kinds of problems.
Yeah. When we tell you to stop clapping during talks, remember they only get 5 minutes, and when you're clapping, they don't get time to give a talk, because we don't stop the stopwatch.
The best way to build rapport with an audience, by the way, is by chastising them immediately, as soon as you start, right off the bat.
Stop.
And then throw your co-host
Try
under the
again.
bus.
Stop. Better. The other complaint that we got was that there weren't nearly enough bad jokes in between the talks today. The good news is that we've had 2 days to become completely exhausted and turn off that filter. Also, I've written a whole bunch of them beforehand, just in case, handing over to my wonderful co-presenter here, the quality of jokes decreases as we swap off, just in case, you know.
I have a spreadsheet that Chris has given me. There are talk titles, presenter names, and then there are jokes in bold.
I have standards.
If you say so, Chris.
I do. It's time to begin the lightning talks. And to begin this block, we have Nick, who's going to be talking about blocks.
It's true. Good joke. Good joke. Has it come up? Has it come up? Is it going to come up? It's come up. Cool. Hello. This is my talk called The Children Yearn for the Minds. It's about importing Ultima 4 maps into Minecraft. Well, not Minecraft. Well, Minetest. Although it's called Luanti now. Who cares why? It's actually a talk about... Oh, stop it. It's actually a talk about procrastination. It's all right, I'll fix that later. It's a talk about procrastination inspired by Ada's talk yesterday, because I thought, you know, young developers tend to procrastinate and find themselves lost in this mine of procrastination. And I just wanted to demonstrate that more senior developers might do the same thing, but harder. Anyway, so I was working on my presentation for, and all my slides are in the wrong order, I think. I was working on my presentation for my thing yesterday, and I was working very hard at it. I had a proposal in, everyone liked it, it was really good. I had a to-do list. I had a bunch of stuff to look up, a bunch of stuff to write, a bunch of slides to make, all of that. It was very, very, very boring. So of course I did what anyone sensible would do, which was so I really liked this game when I was growing up called Ultima 4. It was great. It ran on the Apple II. It was an adventure. There was a whole world to explore. There was so much to do and find out about. And then at some point, the whole world to find out about. And you had this picture of this world, this picture of this place, even though you'd never seen it because it was always in this tiny little window. You had this picture of the place, and you know how places are in games. You imagine them even though they're not real. They're very meaningful to you. And I thought, wouldn't it be cool if I could still have that? And when Minecraft came out, I thought, I could put it in Minecraft. Imagine if I could take this world of blocks and put it in that world of blocks. Wouldn't that be awesome? No picture. And so I had to learn how to read the map. So I learned how to read the map. And the thing is about Ultima 4 is it's so old that nothing could be complicated. There wasn't time. So we hadn't made anything hard yet. So all the map is just a bunch of bytes in a row. They're not the right row, but it's a row. And then I went to write it into Minecraft, and Minecraft's hard and it's in Java, and Minetest isn't, and it's open source, and it's in Lua, which is okay, that's fine too. But also it's got a documented format for its files. It's an insane format. It's completely crazy, but it's documented, or you might call it confessed. It is very complicated. Well, thank you. So this is some of the code that writes it. I promised in my thing that I would have some actual Python code in a talk at PyCon. Hey, there it is. I didn't do syntax highlighting. Get good. Basically, what you do is you output a whole bunch of random binary data and a whole bunch of other data that is meant to do something, but I just put a bunch of zeros there and saw if it worked, and some of it worked. And then you take that, you compress it, and you write it somewhere around here. You write it into an SQLite 3 database as a zlib compressed row, which is just, like I say, it's a confession. Anyway, doing that, you could suddenly write blocks, 16 by 16 cubes of crap into the Luanti maps. This is awesome. So then I looked at, this is the Ultima 4 map, so I looked at that and I went, wouldn't it be cool if I could just pick those tiles up and write them into Luanti? There they are. And then I went, they're very square and ugly looking, but that's okay. There's also towns. Towns have their own 32 by 32 maps. They're one grid scale on the big map, but they're 32 by 32 on the little maps of each town. So you have to pick them up too and put them in separately onto the scaled up map from the big map. There they are. And then somewhere this clicker is not helping me. And then I looked at these things and went, square rivers are ugly, I have to do something about that. So I worked out a way that you could make like rounded rivers, and there it is. And then I put that into there too, and now we have little roundy rivers. That's pretty cool. And then I had this long list of other things I need to do. So I need to have terrain, I need to have mountains coming up and oceans going down. I need to have trees in the right places. There's shrines and dungeons and the moon gates, and there's all this other complexity and stuff. And now I have a really long, tedious to-do list that I really can't be bothered doing. And so the good news is, that's how I finished my talk about bioinformatics. Thank you very much.
Thank you so much, Nick. Up next on this side, we have Ben and Elena. But first, Miss Linda is here to tell us a story. Good morning, Miss Linda.
Good morning, everyone. Slight content warning. There will be a mention of mental health and workplace exploitation. Once upon a time, there was an oligarchy. It wasn't your usual kind of oligarchy. The oligarchs weren't actually in charge. It was a sneaky kind of oligarchy, although it's kind of weird to call it sneaky because it was very, very loud. They weren't just loud, they just weren't loud about being in charge. They were loud in a, hey, look, what's that over there kind of way. The oligarchs didn't think of themselves as oligarchs. Oligarchs very rarely do. Instead, they thought of themselves as benefactors, saviors of mankind, though in truth, the man part was more important than the kind part. It turns out that in order to save mankind, you have to do some pretty terrible things. In their own minds, they were creating a glorious new future, a future in which no one would need to work, or at least no one would need to get paid for their work, which was almost as good. In fact, for the oligarchs, it was better. The oligarchs set about building a device. The device would write masterpieces, the like of which the world had never seen. Or maybe it would be a friend, or even a therapist. Obviously, it would save the world from climate change, and it would absolutely rescue humanity from the need to be creative or interesting in any way. Honestly, it was going to be incredible as long as no one asked the oligarchs exactly what incredible meant. It was going to be all things to all people, that much was clear. Unfortunately, not defining what the device was made for made it kind of tricky to build. The oligarchs scooped up a ton of funding because obviously everybody wanted an all things to all people device, and they were terribly convincing. They built the device and set it free with great pomp and ceremony. It could do anything up to and including flying to the moon. Indeed, it practically had a PhD in flying to the moon. Unfortunately, it flew to the moon in much the same way as a bucket of sewage would. It didn't get very high, and it made a rather stinky and terrible mess when it hit the ground. Undaunted, for they were fearless, world-saving men, they built a second device, feeding it everything they could find, and they were so good at finding things that they even found many things that belonged to other people. But because they were building an all things to all people device, it was perfectly fine, obviously, for them to take the things without asking, because the device was essential to saving mankind. The actual device was amazing. It passed all the tests, knew all of the things. It was just a teensy bit embarrassing when it turned out not to be able to solve all of the problems. It certainly solved some of the problems, which was pretty impressive, actually, as long as you were happy with the answer to 2 + 2 being a kind of bug. But everyone was jolly impressed anyway, because the oligarchs told them to be, and they were terribly convincing. Unfortunately, word got out that the actual device was drinking a huge amount of water, burning up quite a lot of the world's atmosphere, and still not successfully doing all the tricks. But the oligarchs said that there was no way to do it, to build the actual device, and obviously we had to do that. And there was plenty more water in atmosphere where all of that came from anyway, and they were terribly convincing. So they scooped up more money, burnt even more atmosphere, stole even more things, and built the really actual device this time, or Lucifer, as they affectionately named it. And it seemed truly incredible until the word got out that Lucifer had been fed poor and vulnerable people so that they could wade around in the rather horrifically grubby insides of the machine and remove the problematic bits. Of course, they didn't necessarily make it out of Lucifer alive or undamaged, but the oligarchs pointed out that there was simply no other way to build Lucifer or his descendants. And obviously we had to do that, and they were terribly convincing. Of course, this argument came as rather a surprise to the people who were researching ways to build other devices that didn't eat people, burn up the atmosphere, drink all the water, steal all the things, or scoop up all the money, but simply did one thing really, really well. But it turned out nobody really cared about all of that stuff, and so the devices continued to be built. Skipping all of the things. The story doesn't stop there, but perhaps we could choose our own ending.
Thank you, Ms. Linda. I have no idea what that story could have been about, but I'm sure it's very important. Yaakov, you're on deck. But first, Ben and Elena.
Hey.
Ben and Elena.
You-
You have a microphone.
Oh, well, thank you, sir.
Hello, PyCon. How are we?
So far, so good.
That's great. I'm a long-time listener, first-time talker. And I'm here to ask you some questions. Do you like Python? Yes. Do you like the Python community? Yes. Do you like high availability? Yes. Do you like things that are easy to do? Yes. Yeah, I thought that so. Come be a part of the Python Australia community. It's your Python community in Australia the other 360.25 days of the year. We have a website and a Discord. You can use the website to get to the Discord. And we are...
Yeah, so you might be asking yourself, what is a Python Australia? Well, you might note there is a Python Africa, a Python Asia, a Python Europe, a Python Latin America. There is no Python Australia. We believe that there should be. At the end of last PyConAU, in the hallway track, a small handful of us all got together and went, why don't we make a Python Australia? So your next question is probably, who is a Python Australia? Well, we're in the user groups. So if you're not part of your local user group or you do not have one, we recommend you join one. And there's another thing too that we tend to overrepresent on the coding front. There are more code contributors in Australia than is statistically consistent. We are very, very proud, and big shout out to all these people. They are also part of our community. There are many online spaces which many Australians participate in, and we're very proud. You are part of the Python Australia community. There are all kinds of other weird and wonderful things we do with Python. All of you are also welcome, as are all of just, our day-to-day professional Python users. So who is part of Python Australia? Everyone.
And you.
Yes, including you. And you know that thing Chris McIver was talking about in Consequences this morning? This is that. Come join us. We're having a meeting tomorrow in our Discord. You'll find the details there.
I've got one.
No?
So come join us. All experience levels are welcome. We hope to represent you well. We have somewhat come together from all the different states and other small community bodies. We're hoping to represent you and give you a space to be connected to each other.
Thank you so much, Ben and Elena, for giving me a way to hang out with all of you folks after Tuesday. Up next on this side is Christopher Phillips. But first, over to Yaakov. Over.
I should have expected that. Hello, hello. I'm a human and you are humans, and I would like to communicate with you, but this is difficult. As Lily mentioned in her wonderful talk earlier today, what is in my head and what is in your head are two different things, and we need a way to relate them. And so to do this, we try our best with this wonderful thing called language. And it is wonderful. Sometimes it's spoken, sometimes it's written, but it's a great way to try and encode all of my thoughts and ideas, well, most of them, if we're being honest. But these are not just used to make up words. We use these letters as all sorts of identifiers everywhere. Letters are so good, we put them everywhere. We use them for words, we use them for license plates, we use them for registrations, we use them for taxiways, we use them for key areas in Counter-Strike, only A and B, because there's never more than that, and so on. We love using letters everywhere. But sometimes using letters is hard. There are some problems that can happen when you try and encode and decode the magic of thought into some other medium. And one of them is a bit of a pet peeve of mine, and it's very much self-inflicted. And that is, if you want to describe a letter, it has a name. You just say the name. A, B, C, D. Well, 4 in and 3 of them sound the same already. This can be a problem, particularly if you're in an environment where you can't have clear audio. So you've got a phone call that's a bit dodgy, if you're using a two-way radio, if you're in person, if you're wearing a mask, if you have a thick accent, it can be very hard when you have a letter to know exactly which one was said, when it could have been one of 2, one of 6, one of 7. So there is a standard for this. It emerged from civil aviation in the 1960s. There is a clear word that can be used instead of a letter, because aviation really, really loves to use letters for everything. Each word basically has 2 rules. Number 1 is it starts with the letter that it represents, which normal names of letters do not. And number 2 is that it doesn't sound like any of the others. They all sound very distinct. So you have A for Alpha, B for Bravo, C for Charlie. U for uniform, I have heard so many people say U for unicorn. It's close enough. If it works, it works. Why not? Exactly. I'd heard of this. Yeah, cool, something for like cops and firefighters, whatever to use. I didn't really get into it until I was trying to memorize it when I got into amateur radio a few years back. I think I've already shared this picture at PyCon maybe last year or the year before. This was me working with the Waverley Amateur Radio Society on an international radio communications contest. Yes, they have a contest for that. And no, it's probably not as exciting as watching last night's tram driving contest, which I still need to catch up on. But this uses shortwave radio communication, and shortwave radio relies on bouncing signals off the Earth's atmosphere. So as the atmosphere shifts around, other stations will fade in, fade out. It can be very hard to hear them sometimes. And by sometimes, most of the time, in my experience. Particularly if they're in another state or another country. You can reach overseas, no internet, not exactly the clearest signal. Or if you're visiting from interstate or overseas and you're on a plane into or out of Melbourne, you definitely wouldn't want them to mix things up. We've got the taxiway map here. You wouldn't want them to mix up B and C up the top. We've got M and N over to the left. Off the main runway, you've got B, C, G, and E, which all sound very similar. And you really want to make sure you land up at the right spot, and ideally not on a runway, not on a taxiway where there's another aircraft already standing there. But it's not just industry use. I've found uses for this in everyday life. As a practical example, since not everything's digitized, I was on a phone call a few years back with my car insurance, and they wanted my 17-digit VIN, the vehicle identification number, which, by the way, did you know that that's also a standard and it's not just a random series of numbers and letters? But it's really not fun when you've got 17 digits, a bad phone line because they've offshored their phone support to some other country, and so many letters sound the same. It reminded me of Windows product activation by phone, but it was worse. Using phonetics helped a lot here, though not everyone expects it. I was once on a phone call with the police, and when I started using phonetics, our officer just kind of froze, and they're like, "Are you a police officer?" I was like, "No, you don't need to be a police officer to use phonetics." So I strongly suggest people could go off, try learn this. It becomes much easier to read out letters when you're spelling things. And as well as, or instead of, if you want to be cheeky, there's a native phonetic alphabet, and then someone came up with the anti-phonetic alphabet. We have gems like C for Q, Q as in key, and the one I had to Google, T as in oolong. So you can guarantee confusion wherever you go. That's it from me. You can find more of me online at this URL or offline in the hallways outside. Thank you.
Thank you, Yankee. Morgan, you are next. But first, Christopher is going to talk to us about driving illegally.
Something like that. Hi. My name is Christopher Phillips, and I am a recovering game developer.
Hi, Christopher.
I'm currently working at the Curtin Institute of Radio Astronomy, maintaining software at the core of the Murchison Wide Field Array Radio Telescope. And this is a short version of a longer talk I gave somewhere else about a year ago. Let's rewind a few years. Right, as a teenager, the computer to have was the Commodore 64. Yay! Many people? Fans, cool. My friends and I spent a fair amount of time playing computer games, but we're just as interested in the idea of writing them. Many grand designs were outlined on pen and paper, a few code fragments written, but nothing concrete or publishable. High school ended, we went our separate ways, and I dove into an engineering degree at UWA. Now, the degree started out giving you a pretty broad grounding. Even if you were eventually doing coding or electronics, you still had to start out with some mechanical and civil engineering units. This turned out to be pretty useful later on. I'm a big fan of broad degrees. That's also where I became a member of the University Computer Club, pictured in the bottom right there. And I spent just as much time in the club room tinkering on old machines as I did in my formal studies, probably more. Particularly continuing to try and teach my Commodore 64 new tricks, despite its waning commercial value. So that said, although Commodore 64s aren't the thing you can sell games for anymore and make more than maybe a few $100s, a constant with games consoles is they're designed to be cheap to make with only just enough grunt that a good developer can make shinier games than the ones coming out in competing hardware. So given that, when I finally took a run at applying for some games positions a few years later, studios were just as interested in my tales of Commodore 64 fast loaders and sprite multiplexers as they were in my degree. And that helped me get a job at Reflections Interactive in the north of England, helping develop a whole series of driving games. Hands up if you've ever played any of Driver or Driver 2 or Driver 3 or Stuntman. There are some really old people in the audience here. One of my first really interesting tasks was to replace an older 2D racing simulation with a full 3D physical model of how a car accelerates, does handbrake turns and corners. And for that, my first year mechanical engineering was a godsend. A lot of integration of 3D maths and vector arithmetic and things. Now, the third game I worked on marked the company's transition to a new hardware platform, the PS2, and we really wanted to show off how much detail we could get in models of cities like Istanbul and the like. We sent artists out to take thousands of reference photos before they modelled dozens of different districts and all these different architectural styles and famous landmarks. Question is, how do you fit all that into a games console that's only got 32 megabytes of RAM? Short version is custom image compression codecs, clever data streaming systems, and a few other bits and pieces along the way. Cutting a bit closer to the present day, I recently had an opportunity to optimize some code for some spatial ecologists monitoring plant health along creek beds near mine sites in remote areas of WA. They had 10 centimetre resolution area surveys across dozens of square kilometres. That's about 3 billion pixels per site, with each pixel having RGB colour, a ground altitude, canopy altitude, vegetation classification. Way too much to fit into a desktop computer. And their attempts to run the reports, though, have been just fine on small sites. We're really struggling on monitoring entire multi-kilometre creek beds. Even if they threw more hardware at it, it just ran for a week and crashed into me. I noticed that's really not that different to grabbing just enough imagery off a game disk to render the scenery along a route taken by a car tearing across a city. So I improved the usage of NumPy, made it a bit more idiomatic, a few less loops in Python, a few more in underlining C, but also used a lot of game development techniques for optimizing the calculation, streaming tiled, compressed data to reduce memory footprint, I/O bandwidth, and storage requirements. Through all this, managed to get one of the reports down from taking a week and probably not even finishing to taking about half an hour on a desktop PC in the office. I was pretty happy with that. I know all that without moving away from Python. Didn't have to rewrite a single line in Python or Rust, in C or Rust, Python all the way. Moving on. My current position started out with lunch with another old uni contact who organised with his team leader. I wasn't that keen on commuting, but he was like, no, just come and have a chat with Greg, see what we've got in common. I shared my stories of compressing and streaming vast maps of data, how video games had been useful prep for spatial ecology, and how I'd been messing around with Fourier transforms for various things on a range of platforms over the years. In return, Greg waxed lyrical about a novel radio telescope featuring thousands of little radio antennas scattered across the desert that steered by changing the delays with which they listened to signals rather than moving big dishes around. At the core of the telescope were some monolithic C programs thousands of lines long, running a little server a few kilometres down the road from the receiver. They collated heaps of data, cross correlations and things.
Thank you so much, Christopher. Stop! Well done, everyone. Thank you so much, Christopher, for taking us on a whole bunch of different topics. Up next on this side is Matt Cengia. But first, taking us from running rivers to runtime semantics is Morgan Bartholomew.
Hello, everyone. Today I will be talking about binary operation runtime semantics and their type system implications. So I hope to explain what is happening in this expression by the end of this talk and what it means for type checkers. So if we look at a simple case of an object that supports a binary operation, in this example plus, we just have a add dunder. Fairly simple to understand. We would then move on to the right-hand dunder, which operates when the value is on the right-hand side. We also have the inline dunder, which is called when you use the plus equals augmented assignment operator. The way that these work in combination is that one dunder will return the not implemented singleton, which will then pass the execution on to the right-hand side object's right-hand version of that dunder. So in this case, it would call the add dunder, which will then return not implemented, and then it will call write our add dunder and return 3. The next complexity in this system is the right-hand subtype rule. So what this means is when the right-hand side is a subtype of the type of the left-hand side value, then the interpreter will invoke the right-hand dunder first before moving on to the normal dunder. These all combine when using an augmented assignment operator. So in this case, we will see the iadd being invoked first. It supersedes the other operators. Then the add operator, then the radd operator. A re-implementation of this in Python would look something like this. We start by checking the iadd. If it exists, we call it. If it returns not implemented, we move on. We then go through checking the radd. We check the subtype rule. We would then move on to checking the add, and then finally the radd if it was not invoked previously. If none of these exist, then we'd raise an attribute error. So what do these rules, what implications do they have in the type system and type checkers? So currently, if you annotated the return type as not implemented, all of the type checkers will not understand these semantics and will say that this operator returns not implemented type, when in reality, this will raise an attribute error. This results in some unsoundness when this value will actually return a string, but the type checker thinks it returns an instance of not implemented type. In this case, at runtime, it's returning a string, but the type checker thinks it's returning an int. Oh, and by the way, I'm using ty for all of these examples. Here, when we have a right-hand operator that returns an incompatible type with the left-hand operator, it's very important that we understand what the possible value will be. In this case, ty, and it agrees with MyPy here, that it would return int, which is wrong. It'll actually return a string. And this is because these type checkers have implemented the right-hand rule incorrectly, and it assumes that because the left-hand side is a left, and the right-hand side is also a left, it does not take into consideration the possibility that the right hand is actually a subtype of the left hand. So it will say it returns an int when it will actually invoke the right-hand operator and not the left-hand operator. In this case, we have the inverse, where the right-hand side is being, the other way around. The left-hand side is a subtype of the left-hand type. So the type checker here thinks that the right-hand side is a subtype of the left-hand side value, but actually the value on the left is a subtype of the left class. And the right-hand side is not a subtype of this imposter class. So the type checker is incorrectly applying the right-hand side subtype rule when it shouldn't be. And it says it returns a string when it will actually return an integer. So how can we fix this? How can we update the type checkers? What possible rules could we imply to, or what rules could we add to get the correct behaviors? We can add validations on the subtypes for the corresponding right-hand side operators when they have an incompatible return type with the supertype's left-hand side operator. We will say that this has to maintain compatibility. More examples? More examples. Hey! Thank you.
Thanks, Morgan. That is one of my favorite types of talk. Brianna, you are on deck. When I was scheduling today's lightning talks, I had great difficulty trying to figure out what to follow up a talk about binary operations with. Anyway, here's Matt. Please make them welcome.
Thank you, Chris. Can you all hear me? Yep, cool. I suspect a lot of you have heard about or used Jupyter Notebooks before. If you haven't, Jupyter Notebook is a way to basically via a web page create a notebook of information that is interactive and has runnable Python code. Jupyter Notebooks and Jupyter Lab and IPython have been around for quite some time now. I think that they've built a bit of a legacy and have got some historical design decisions that I think that we could do a little bit better with these days, with now that we've learned from some of the stuff that's been done there. And a couple of years ago, I learned about a new up-and-coming notebook framework called Marimo. And so I'm going to tell you a little bit about it. So let's have a look at this. This is an IPython notebook for now. A Jupyter notebook. So we've got a notebook. It's running in our browser. If I go to display the contents of this notebook, so we're looking at the file that contains the Python notebook. If I have a look at that, this is what happens when I do live demos, right? So the issue here is that I have run a cell, and that cell depended on the output of another cell. And so I have to run the notebook in a particular order, potentially sequentially from top to bottom, but not necessarily. In this case, I might want to put all of my imports for a notebook down the bottom out of the way and be able to use those further up. But I can't do that easily with Jupyter because it's not going to know to go and run that. So I'm going to go to the cell below. I'm going to pull in my imports, and then I'm going to fail miserably. Let's open that one, run that one as well. There we go. So we're looking at the contents of this notebook file, and we can see it's a whole lot of JSON. It's not super easy to maintain or work with, and if I wanted to just run this as a regular Python script, I'm going to have a few challenges. I'm going to have to go and convert it. It's a bit of a pain. So let's have a look at the way Marimo does this. So if I open up my Marimo notebook, if I have a look at the contents of this notebook, I need to go and enable this cell. This notebook is pure Python. So it's imported Marimo, and each cell in the notebook is an anonymous function. So we can go and copy the code out of each cell and put it into a regular Python script, and it will just work. You can also use Marimo to run the notebook as a regular Python script. And it's, I think, rather easy to read. So if I go a little bit further down, one of the other benefits of Marimo is that it's built in with a whole bunch of stuff that didn't come with Jupyter notebooks, but is available as add-ons. But Marimo has a lot more stuff that they make natively available. One of those things is DuckDB. So one of the things that I can do with DuckDB is I can say I would like to open a JSON file and put it into a pandas data frame, and I can view that data frame here in a pretty table with a whole bunch of frequency distribution stuff. And then what I've done to view the table is I have used raw SQL. I haven't had to do anything else in this cell. This is an SQL cell, and I've been able to use raw SQL to display the contents of this spreadsheet, this table. Likewise, I can use other raw SQL where I can go and filter it. I could change this to Europe, and it'll go and change the contents there. And the other thing that I can do is I can have, and this is available again in Jupyter as well, but I feel like it was a little easier for me to get this working in Marimo, was that I can add a widget here, and I can say, show me cars that have at least this many miles per gallon. And we can also see that way down the bottom here are my imports for Marimo and pandas. And the way this works is that if I go back up to the top here, I've got 40 seconds, this is fine. If I go back up the top, we can see that the cell at the bottom returns my two imports. And if I go further up to the top, where's it gone? Here, we can see that it takes in a lot of those imports as arguments so that it can do internal dependency ordering without me having to think about it. And if I were to run this cell, it would make sure that all of the prior cells have already been run. There's a whole bunch of other stuff that you can do with Marimo. I highly recommend you check it out. Marimo.app and marimo.io are the URLs.
Hey!
Thank you so much, Matt. While lightning talks are going on, we're setting up the next person, but all I could just hear is oohs every 10 seconds. I'm really excited to go back and watch that one. Up on this side next is Evan, but in the meantime, it's not lightning talks unless there's some controversy. So Brianna Argall is here to talk to us more about fish.
So I thought it would be... I thought, given that it's my first PyCon, the way to make a good impression at the start would be to challenge something someone said yesterday.
Stop.
So, why listen to me? To establish some credibility, I'm currently a Masters of Health Data Science student, but previously I majored in ecology and conservation biology. And as part of that, I did an honours project, and I've copied some slides directly, that had nothing to do with taxonomy or classification. But as you can see, there's a picture of a fish on this slide. And if we look at the next one, it's got some equations and there's some partial derivatives, so clearly I'm a very technical and competent person. So let's get on to the content of phylogenetic trees. These can also be called cladograms, and what you can see is the relationships of ancestry here. So you've got some common ancestor, branches down, and then you can see the subdivisions of the phyla there. In a monophyletic tree, you have the recent common ancestor, and all of the descendants are grouped together into the one monophyletic group. Another example of that is shown in this instance. But, controversially perhaps, other types of groupings are possible. So we can see here we have a polyphyletic grouping, where you do not have everything flowing from the one common ancestor. We have different most recent common ancestors involved. So the takeaway here in terms of interpreting a phylogenetic tree is that in a monophyletic group, you do need to share the common ancestors, and so that rule about if these members are in the group, then we know that this other member, such as humans, for instance, has to be in the group as well, would hold. If you don't have a monophyletic group, that's not necessarily the case. I thought for my talk I would bring up the definition of fish. And so this is the first screenshot I found. I just went to Merriam-Webster. And here it actually presented me with somewhat of a problem. You might see I've put a box around starfish. And the problem here is it shows me as a bit of a hypocrite, because I looked at that and I went, that's not starfish. We should be calling them sea stars because they're not fish. And I know that because of phylogenetics.
Stop.
If we look at the next proposed definition, we can see that it's describing some of the characteristics, so it's telling us about the morphology, and we have that included in. So I prefer the second version, sits happier with me. But my morphology-based definitions can be quite limiting and have their own issues as well. So if I say, for instance, that a mammal is something that produces milk and it has fur, then plenty of mammals could be categorized under that. But you might also have a bad drawing of a coconut. But if we want to use this phylogenetic-based approach, then we might want to consider what are our nodes, and usually when you zoom in at the bottom, you might have different species. So it's important that we can consistently consider what is a species. If we look at the process of something becoming two different species, we start with the one population, they become more different over time due to limited gene flow. Typically, this is some geographic barrier. And then because they're not having that gene flow to keep them more similar with each other, differences increase until eventually they get to the point where we've got these two subpopulations that have split off. They're so different, members of them can't create fertile offspring with each other. And according to the biological species concept, that's when they're different species. But there are many issues with this definition as well. So, for instance, we have ring species. Imagine a group of lizards all around this canyon, and pairwise they have that compatibility, but the ones that are far across from each other don't. Would you consider them the same species or not? Another thing we might consider is, what if they're an asexual type of lizard, and so we don't have that reproduction criteria to look at? Or you could think even differently, what about if we have viruses and you've got horizontal gene transfer? So there is no perfect, objective, generalizable rule set for classifying life. My righteous indignation that I had yesterday might have been a little bit mistaken. And I think the takeaway here is to consider what makes sense for your users and what makes sense for the purpose and context you're applying it for. Thank you.
Oh, thank you for that. I love these response talks. If you want to give a response talk to anything today, you've got a whole year to think about it, which is going to make you look extra deranged and like you're holding a grudge and such, which we really like. So do be thinking about your response lightning talks for the next 12-ish months. Ash, you are on deck. Evan's not your parents, but he is going to tell you how to eat.
Hello. Hello, can you hear me? Okay, great, awesome. Hello. Now, I'm not a fruit connoisseur by any means, but I've noticed that no one knows how to eat fruit, so here we go. First, we'll start easy with oranges, the most illustrious of all fruit. Cut them in half and then into thirds, and this allows you to easily eat off the individual segments by bending the skin. Mandarins, kind of like an orange, but the inner segments are already pulled apart. Peel off a ribbon of skin with your fingers, and then keep the hemisphere to hold the skin and the seeds. You have an apple, classic. You take bites out without peeling, and once you get to the core, don't be wasteful and stop. Finish it off. Nothing bad can happen to you since they keep the doctor away. Pears are basically messily green apples, best cut into slices. Prickly pears are not pears, but the fruits of cacti. They are covered in spikes, and they're best eaten by quickly torching them over fire, washing, and then filleting their skin to reveal their juicy innards. Tomatoes are not vegetables. They have seeds inside, and thus they are fruit. Cut into segments and top off with your favorite salt. Honestly, delicious. Lemons are popular ingredients, but they need more love than that. Have you tried eating them raw like an orange? Very nice. Strawberries. They are not berries or fruit. They are the thing that holds the seeds, which aren't seeds, but the fruit itself. Anyways, just cut off the green part and eat them whole. Avocados have a seed inside and thus are a fruit. First, cut along the shortest axis to minimize surface area. It will last longer. Then, spoon out the flesh, throw away the flesh, and keep the seed to admire its beauty. This is why they're so expensive. Banana, the ultimate weapon. Most people would eat a banana like this, peeling from the stem, but this is a grave mistake. Even primordial primates will get this right. Pinch from the tip and eat as you do. Figs, another one that's not actually a fruit, but a syconium, which is an inside-out group of lots of teeny tiny flowers that all bear not seeds, but fruit. Like an inside-out strawberry. There's no leaves on these, so just eat them whole. A kiwi, often mistaken as the bird due to resemblance, normally cut in half and eaten with a spoon, but best eaten like an apple with a skin on, letting you eat it wherever you are. Mango, most people cut off the cheeks to dice, but have you tried peeling off its skin? Now you can eat it like an apple. Blueberries. Did you know that blueberries can be white on the inside? So when you're eating them, make sure to cut each one in half to double check before devouring them whole. Grapes, the fruit of the gods. Most often mistakenly eaten whole and one by one, but should actually have their skin peeled before consumption. Try it, you really don't need the fiber. Blackberries? Oh, wait a minute. Yeah, they look the same to me. And if you think about it, no one eats grapes whole with the vine, so make sure you pluck each one individually to savor them as much as you can. Pineapple, my favorites. They're actually made through a fusion of flowers that are out to kill you with their spikiness. Although there's some cutting methods that are superior, they're all difficult, so just hack at it with a peeler. Chilies are my arch nemesis. You can see they have seeds inside, and thus they're a fruit. To eat, don't cut them like this. Cut them head to tail, remove all of the seeds, and since it no longer has seeds, it is no longer a fruit and can go in the bin. This talk, for some, might have been funny or infuriating, but why should we shame people for their preferences or upbringings? Eat fruit however you want and apply that principle to the rest of your life. Thank you.
Thank you, I think.
What?
Yeah. Up next on this side, while I process what just happened, is Alex Verrico. But first, we've had a talk from Brianna about genes. We've had a talk from Evan, effectively about genes. So we had to tie it up with a third talk about genes. Please make Alex feel welcome.
Hi. I'm here to talk about pants, or as Daisy alluded, jeans. So, who here is wearing jeans? Can I see a show of hands? A lot of you. How many of you have a favorite pair of jeans? Do you know why it's your favorite pair of jeans? I don't need an answer now, but come see me after the talk. I would actually genuinely love to hear about it. So, last year, this pair of pants was voted the best pair of jeans in the world, or rather, the best faded pair of jeans in the world. Look at those whiskers, those combs, those stacks. Very impressive stuff. But Ash, you ask, how do we judge the best pair of jeans in the world? Well, enter this happy-looking Swedish man on the right. His name is Rudi Krara, and he runs the Jeans Museum with over 14,000 samples that he's collected over the past 50 or 60 years or so. And he's the final judge in a jeans fading competition called the Indigo Invitational. Now, the Indigo Invitational goes for 365 days, and some people have very specific techniques and strategies to their jeans fading. The most dedicated will go as long as they can without washing their jeans, aiming to produce higher contrast wear patterns, some even going the whole year without washing. Here's a pair the day that the competition started last year, and this is what they looked like at the end. Yeah, a little gross. These jeans look like they've had a pretty rough life. This is absurd, right? Surely only the most dedicated, most hygienically challenged people would ever consider taking part in this competition. So naturally, I decided to enter. This is the pair that I chose this year. I'm wearing them right now. It's a 14.5-ounce double black jeans from Nudie. They worked for me in a style that I liked. They're roomy enough for me to climb in. I think they're pretty neat. They've got a little orange selvage ID, sulfur, rope-dyed warp, and a color-fast weft. I don't have time to explain that. Ask me after the talk. And I think they should produce some interesting outcomes. So, why enter this competition? Well, in a world of fast fashion, constant trend cycles, and pre-distressed items, personalization of an object through consistent dedicated wear becomes a little bit of an oddity. And if you're really odd like me, you're also probably interested in the way that objects build memory and meaning through their use. Your jeans become a record of all the experiences that you have while wearing them. Things like where you put your wallet, that weird coffee stain, the tear from falling off your bike that you patched up with scraps from another pair. A vessel of memory and nostalgia. Jeans also carry social meaning, originally a symbol of the working class, and then progressing into rebellion and counterculture. While they do not exist solely in these social domains anymore, these meanings are firmly embedded into their aesthetic and can imply certain levels of social status and group belonging. Yes, I did just reference semiotic sociology and phenomenology in a lightning talk. I know you would love to hear me talk about Foucault, Baudrillard, and Marx, but sadly I don't quite have time for that. So, competition started 2 weeks ago. What's happened since I started? So I wore them to PyCon. I'm giving a talk in these pants. I wore them when my partner was taken in for a surgery that they had been fighting for years to get. And I was wearing them when I learnt that my grandfather had passed away. So in just 2 weeks, these jeans have shared quite a lot of experiences. Hopefully the rest of the year goes a little bit smoother, especially because now I kind of need to provide an update at next year's PyCon. Thank you.
Well, they say you are what you wear, and I think for you, doubly so. If everything goes well and you're at next year's Lightning Talks, I think you'll probably still be wearing them. So say hi to Ash now. Hey, cTrix, you're on deck. Alex is going to tell us something about being done.
G'day, everyone. All right, quick disclaimer before I start. I am not here on behalf of my company. All stories that I share are my own, and my opinions are also my own, not my company's. There's a QR code on screen right now that links to notes about this talk. I'll also show it later. I love the motto, done is better than perfect. And today I'm going to give an example of when that's a bad idea, and also some practical ways to apply it when it's a good idea. My house is majority solar powered, which is great because no power bills, but I do work in IT, which means lots of devices using lots of power, and so I'm constantly watching my solar system. How much power is being produced? How charged are the batteries? How much power am I using? And so on. A while back, I got sick of always going outside to check on everything and decided to try and get remote monitoring set up. A quick Google search later, turns out my system has a built-in Wi-Fi dongle and an app to view everything about your system that doesn't require a subscription. Once I registered an account in the app, it asked me to enter the serial number of my system, then immediately started showing all the information I wanted. Great, job done, no more going out in the rain at night to check on the batteries. A few weeks went by and this monitoring was working great. But then I started to wonder, do I trust the manufacturer of my solar system to have done a good job of building this monitoring system that they are offering for free? Surely they're trying to keep the cost as low as possible since they're not charging for it. So naturally, I started digging. I'm not going to go into depth about how I discovered these issues since this isn't a cybersecurity talk, but let me summarise the main issues here. No HTTPS. Both the connections from the system to the server and from the app to the server were unencrypted HTTP, a perfect example of done is better than perfect being a bad thing. No verification that you own the system you are trying to control. Just put in a system ID, you can control it. This means you could easily disable overcharge protection for someone else's batteries and start a fire. This on its own wouldn't be terrible if it wasn't for the final issue, sequential IDs. So I immediately disabled the Wi-Fi dongle and started looking for other options. I found an amazing GitHub repository where someone else had already reverse engineered the USB communication protocol for the system, and so my focus turned to building a basic program to record, store and display all the data I needed. I split this into 3 distinct parts to make it easier to work on and marginally more secure. Part 1, the monitor. Connects to the system by USB, queries all the parameters I want, stores them in a SQLite database with the timestamp. Pretty simple. Part 2, Solar Viewer for the web. Serves a basic web page using Flask, which renders data from the same database. By this point, I've accomplished part of my goal. I'm recording data and I can view it on my local network, but what about remote monitoring? Because I've adopted the done is better than perfect motto for this project, I haven't built any kind of authentication system, I haven't set up HTTPS, and I don't want to expose my hacked together code to the internet. So what now? I want to introduce a concept some of you will already be familiar with, risk outsourcing. This basically just means palm off the risk to someone else, so here's how I put that into practice. The third part of my monitoring setup. Discord. A basic Discord bot that connects to the same database, renders the same data as the web viewer, posted in a Discord server. A perfect example of how you can embrace done is better than perfect without compromising on security, by outsourcing risky components to well-established products. So, how can you adopt the motto of done is better than perfect? Just start coding. If you have an idea, you don't have to plan it out well enough for it to scale to thousands of users. Build it in a way that works for you, then come back to it and enhance it if you want to, or don't. Done is better than perfect. Second, outsource risk. For example, many projects can use Discord or a Telegram bot or many other platforms to provide secure remote access with very little effort or risk. Third, share your projects. Sharing your projects has a great side effect. Over time, you will start to automatically adopt good practices, such as using config files instead of hard coding, maintaining a requirements file, and writing down the setup instructions. Because believe me, it seems obvious how to set it up today, but it won't be obvious 2 years and a dozen projects later. Fourth, be transparent when sharing your work. Add a disclaimer if you don't think it's secure, or a note if you think something could be improved but don't have time to do it. And finally, encourage contributions. Your Hack Together weekend project probably works great for you and only you, and that's okay. Remember, done is better than perfect. But maybe someone else will make it work for them. And remember, review their changes in the same context. Done is better than perfect. Thanks.
Stop. There we go. Well done.
Did we just cut him off before he was done?
No.
Oh, hey.
No, I was waiting for the 0. So thank you so much, Alex Verrico. Unfortunately, up on this side is... I did it again. Sorry, Peter. Unfortunately, up on this side is not a lot of lightning talk. Fortunately, however, it is our lovely conference director, Peter Hall. But in the meantime, we've just had Alex Verrico, and now we have another AV person to talk. Please direct your complaints about that joke to Christopher Neugebauer.
Classic.
That was literally that was the one that he was the most keen on out of the spreadsheet jokes. All of the jokes that I've made on stage here that you've liked, those are mine. Anyway, Chris has been a core part of our AV team since 2020. Multiple conference organisers, including myself, have trusted him with basically everything that makes this conference run. And based on what I've seen from the submission, I'm about to learn that whether or not I should have had that much trust, we'll find out.
Hey everyone, there is audio in this, just to let you guys at the back know. So this is titled, Is There Secret Data Encoded into the PyCon AU 2025 logo? Let's have a look. Well, at the start of each of the conferences for the last few years, we've had something called a bumper, and it's it wakes people up, and it also says, oh, we're about to start. So some of them we've had is this one. Now, I don't draw the logos, but I animate them. I do the sound effects that go with them. And this year, we had this beautiful logo by Robert Schulten. Big clap for that wonderful human who made this great logo. And I got inspired by this little bit up here, which to me reminded me of a 1980s tape loader. What is a tape loader? Well, back in the 1980s, we had computers like these, which loaded from tape. This is a Sinclair ZX Spectrum. Yes, you put your tape in the tape machine, you push play, and often while it was loading, it would do things like this, which has audio. There we go. So you can see there, the black and white's loading with audio as it goes, and you hear the data. And there we go, you see it in the logo as well. So that's where the inspiration for that came. But if we take that audio and we put it into an audio editor program, and you can do this from you can rip it off YouTube when you get home and try this, you'll notice that this weird thing happens if you look with phase analysis, the difference between left and right. So at some point in this, the left and right speaker actually flip so you can cancel the audio out. And if we combine the two together, you'll see this little block of data suddenly appears. Oh, what's this? If you've ever used a Spectrum, you'll know what that is. That's the sound of a tape loading. Is it? Well, let's find out. So we're going to delete the waveform off the start and the end of this logo bit of audio here. And if we look at closely, that looks awfully like frequency shift keying. For those of you who are into radio, you'll know what that is. So what we're going to do is save it as a creative voice file. No one's used these since 1990, but that's okay. We're going to use it here. So we're going to save this as logo.voc. Now, that is just the audio from our introduction there. And we're going to load it into a program called DOSBox, or an emulator. We're going to use a little program here called Taper, which is for reconstructing virtual tape files from audio. We're going to take our logo audio, we're going to pull it into Taper, and we're going to open that creative voice file. And In particular, there's this pilot detection, which is a little ding at the start that tells the Spectrum, oh, are we running at the right speed? And it does a whole load of calibration. Turns out you can make that really short, which is what we've done here. And so instead of giving it 10 seconds, we've given it just a half or fraction of a second. You see PyCons, something's happening here. What is happening here? Let's find out. We're going to save this as a .tap file, which is a virtual tape file. So this is the virtual tape of the audio from our logo that we've been watching for the last 3 days every time something starts. It says, we don't fully understand this format. No, it's got some weird conference audio in it too. So it'll say, do you want us to save it anyway? You say, yeah, don't worry about the other bits of audio in there. Just save it and see what happens. So it's now going to save that as a tap file. What do we do with a tap file? Well, we load it into an emulator, the free Unix Spectrum emulator that we're running in Windows. So you can see here we're going to go tape. We're going to open that virtual tape file. And now with that tape file open, we're going to reboot our machine. So you can see it's a hard reset, nothing in RAM here. So this is an empty Spectrum. We need to look at the keyboard to know to press J for load, and then Control and P twice for the inverted commas to get the two load things. And then we press play on our tape. And our tape goes play. That's what inspired the logo. Hey, what have we found? Bit of data. That's the data you've been listening to for 3 days. And what do you know? We press run, and we have a piece of software.
Hey.
And because we love open source, if you push any key at the end of this, it will actually give you the source code and you can start playing around with it. It's written in BASIC. It was about 140 bytes worth of data. There was a few things with this. To get it short enough to fit it in the logo was a bit of fun. Also to make it so that it wouldn't get affected by MP3 or AAC encoding. I've tried encoding it with heaps of different encoders. I did a whole load of filtering on the logo soundtrack to make it so it didn't cut out. And also had to make sure the venue could play it in stereo, which they couldn't. This whole room is mono, but we figured out a way of not having the cut out. And then finally, thank you to the organisers for letting me do a lightning talk. And if I'm just changing the code down here, because we can, because it's all open, and you can do this too if you load this off YouTube later, I'd like to thank you for letting me do a lightning talk.
So for those of you on the live stream or who buy an online ticket for next year, please actually stay and watch the talks and don't spend your time trying to hack apart the audio. We really do want you to watch the talks. That's the end of the lightning talks.
I'm supposed to like vamp now, but I'm still just like struck by. I'm impressed and also betrayed.
And it's one of the best Curly Boys I think we've seen in the however many years it's been since Curly Boy's been a thing. So thanks for that as well. While we're doing thanks, thank you to all the other AV people for doing the amazing job you do making this run actually smoothly.
Seriously?
Thank you to Benno, who has been our stopwatch holder for the last 2 days. We normally have him on cue. The stopwatch holder. We have him on deck to do interpretive dances when the AV fails, but the AV people did their job, so you didn't get to see any of that this time.
Genuinely, when we book venues for PyCon, we tell the venue AV people about lightning talks, and their reaction is always consistent that you want to do what?
And it still works.
Yeah, it's still like massive testament to the venue AV team and especially to the PyCon AV team led by Next A Video.
Thank you to all 13 speakers from today's lightning talks. You've been fantastic as always. Thank you, Daisy, for being the wonderful co-host for this year's lightning talks.
And thank you so much to Chris for coming back and hosting lightning talks with me once again.
Hey, it's me. That is the end of lightning talks. Please give a huge round of applause to our fearless conference director, Peter Hall.